So I'm going to try to like explain how I went about doing this project. And so essentially what I did was I got the Attack on Titan IMDb reviews of IMDb, and we have the head here. And after that, we're going to convert the object into a date. This makes for easier analysis or something that we need to look at later on, for example. And here is where it starts to get a bit tricky. So we are going to use Beautiful Soup to basically get the HTML code from the Wikipedia site. And what I'm trying to do here is I'm trying to get all of the episodes from Wikipedia, and essentially uh, I need to find I need to attach every review to a particular season. So that is what I'm trying to do. Now, of course, I have added a bit of complexity to it just for my own knowledge gain. Uh, Now, here we were running with a lot of problems. So you'll realize if you're working with Wikipedia that there are a lot of problems when it comes to like importing the data. And in that particular situation, what we're going to do is we are trying to figure out exactly where the issue was happening. And here we kind of understand it because the table 5 are the special episodes, and we did not need that, and that is why I was constantly processing 5 seasons, whereas Attack on Titan only has 4. So what we do is we skip the last table because we don't need that. And once that is done, we will go in the particulars of each table, and essentially what we are going to do is we are trying to get the date of every episode and every season. So we're trying to extract all the tables that we have. And this is me basically just confirming that we have everything correctly. So we have the first 5 entries from season 1 and the last 5 entries from season 4. And here we did some things that were wrong. I kept it in here just to show that there were a lot of challenges that were being faced. So after that, we basically assign we basically change the names of the columns. So we have a season, we have the episode number, and then we have the release date. And we also do the regex pattern. So the regex pattern is basically we just want this format of date, and everything else that Wikipedia gives with it, we have to remove it. And over here, you can clearly see that it has worked. So we got like the actual date, the actual release date, along with the episode number. Yeah, so this is again like some things that I did, which weren't exactly heading in the right path. Anyways, now we group the seasons according to each, like the dates that they aired. So now we have the start date, the end date. Now here's the problem: season 4 wouldn't have a next season start. So in that particular situation, what we're going to do is we're going to copy our review file, and we are essentially going to so essentially what's happening is that since we don't have season 4, we are just going to map it as post show reviews here. Now, time delta is like we're using it just to subtract just 1 day from the next season start, just so we can basically map the reviews properly. And once that is done, we are going to have our ratings, our title, full comment, and the date that it aired. And now, as you can see, it is attached to the correct season as well. So this was what we were trying to do. This was something that I forgot initially. So I came back to basically remove all the no content reviews because they aren't actually serving any purpose. After that is done, we are going to plot the reviews, the amount of reviews that we received throughout the show. Makes sense. Season 2 and season 3 had a very short sort of boundary, so we did not receive a lot of reviews for season 2. And here is where we did like a sentiment analysis. So we use an existing tool called Vader, and in Vader, uh, it's a built-in library. So essentially, what it does is it tries to understand what is being said, and it assigns the score from -1 to 1. So that's what we did. And now we have a sentiment score for every comment that we had. We are it by the season, and you can see that it's got 0.7, 0.4, 0. And I do believe that that is incorrect, because like it can't be that low. So here we just simply just like plot it. Uh, so here's where it gets interesting, like the interesting part of this project, where I was like, maybe we could use AI to train the data, and we could we could use AI to label the data, and then we can train it afterwards. So this was essentially what I started doing. So I created an app, which was uh, basically just we needed to upload our file. And what basically happens is, once this file was uploaded, uh, all the rows, like the Gemini API went through the rows one by one, and it kind of labeled everything between -1 and 1. And I set up like exactly what it needed to look for in those particular reviews. So I set up the criteria on which it was supposed to be judged. So here, of course, we are going to create split. How 20% of it is going to be used for training the data, testing the data, and 80% for training it. And this was like some, oh yeah, so this code, you can use it directly as well if you have money in your API key. So I wanted to basically make an application and use it through that, but you can also use it within the collab environment as well. So what happens now is we convert our existing. So essentially, what's happening is that we have the previous 500 things that we 500 reviews that we basically put in our the app that we created through AI Studio. And after that is done, we need to find out if we actually did it correctly, right? So in that particular situation, what we're going to do is, once we're going to split the data, we are now going to understand if we can actually, like, if it has been actually successful. So here we are going to do a linear regression. So why we're doing a linear regression is because we need a value from -1 to 1, and it is in binary. So we need a continuous variable here. Another important concept here is of TF-IDF vectorizer, which is essentially we are assigning values to each word in a sentence. So, for example, this is the greatest show of all time. So, greatest all time will have a higher value in that particular situation. So, we are basically going to use those vectors against the review that we received in order to train in order to train the model that is left behind. Like, there are 2000, around 2000 more reviews that we haven't trained yet. So once this is done, we have a 0.16 mean absolute error, which means that um, yeah. So if somebody is interested in the maths, since we are calculating from -1 to 1, that's a distance of 2. We divide 0.167 by 2. So that means that whatever answers we were getting when we were testing the data were within 8.3% of the answers, and that is really good. So now we are just going to predict the rest of the model, which we already had. So this was like the DFML, which it was called, and we're going to clip it, which means we are going to max it out. So sometimes what happens is that when we are doing a linear regression, essen- essentially what happens is that it can predict values greater than 1 as well. So we don't need that. So that is why we're going to just clip it out. We're going to make sure that the values that we receive are between -1 and 1. Once we run this, we know now that we have our maximum score and our minimum score, and now we are going to group it by season. So now you can see we have a much higher number. So this basically means that this has been better in terms of analysis, because the main problem with Vader is that if somebody says this has been the greatest disappointment ever, Vader is going to think this has a positive connotation instead of a negative one. So we are trying to basically avoid that particular situation. And by the end, of course, we are going to just plot out the graph, just to basically show our comparison side by side. Thank you.